Hello everyone, this is Baiju Vasudevan. Welcome to my channel pibyme. Today we are going to learn Chapter 2 Quadratics from Pure Mathematics 1. If you take a look at the Chapter 2, it has like 5 subtopics 2.1 to 2.5. So what can you expect in this chapter, the Chapter 2 Quadratics? You can expect solving quadratic equations by factorization or product sum method, or solved by formula, or solved by completing the square. Then you will have functions, which is a new thing that you are going to learn. Then after that, sketching the quadratic graphs. We are going to sketch the quadratic graph. So what are the things that has to be taken note before we sketch a quadratic graph? So we are going to learn that. Then we have discriminant. You know, when you write the formula, you usually write square root of b square minus 4ac. This b square minus 4ac is the discriminant. So how do we use this discriminant to predict the nature of how the quadratic graph is going to behave? So let's start with 2.1. 2.1 is solving quadratic equations. You have two exercise 2a and 2b. Exercise 2a is completely based on factorization, or you can use product sum method, and 2b is for formula, quadratic formula. You need to solve the given quadratic equations by using the formula. But even though when we use product sum method, when we solve these quadratic equations, sometimes you will have questions like this. This question has been taken from exercise 2a. You have this quadratic equation. They want you to solve by factorization. So you don't need to use product sum method. When you have like this, you can just take a square root on both sides. So this will become 2x minus 3, and 9 square root of 9 is plus or minus 3. It can be plus 3 or minus 3. So split them into two equations. 2x plus 3 is positive 3. And take negative 3. 2x minus 3 is negative 3. And when you solve, you got two solutions of it. If you try to expand this and bring the 9 to this side and try to apply the product sum method, it's a long process. You don't want to do that. This will be the easiest one. So bring the 3 here. So your 2x is 3 minus 3, which is 0. So your x is 0. Basically your x is 0. Here when the 3 comes here, minus 3 comes here, your minus 3, 2x, sorry, this is supposed to be minus 3, I'm sorry, I made a little mistake. So this is 6, 3 plus 3 is 6, x will be 3. Here it will be 0. 2x is minus 3 plus 3 is 0, your x is 0. So you got two solutions, 0 and 3. If you want, you can expand and apply this product sum method. You will get the same thing, but this is the easiest way. Question number 2, they want you to solve this quadratic equation by factorization. So just square on both sides. It will become x square and the square root will be gone, 8x minus 15. And when you put everything on one side, you will have x square minus 8x plus 15 equals 0. You got a quadratic equation now. You know how to solve this equation already. You can use a factorization method, product sum method. Look for two numbers which are multiplied to 15 added to minus 8, which will be minus 5 and minus 3 if I'm not wrong. So you will have x minus 5 into x minus 3 is 0. So your two solutions, 3 and 5. That's it. So it is not difficult. I'm not going to talk much about this factorization and formula. Formula, you need to remember this quadratic formula. Minus b plus or minus square root of b square minus 4ac upon 2a. This is the quadratic formula. So when the question says solve the equation by formula, you need to use this formula. But the common mistake that the student make, when you are given a function, something like this, maybe take the same function. Minus 8x plus 15 is minus x squared. Let's say this is the given function. You are not supposed to take minus 1 as a, minus 8 as b, c as 15. you always need to write the equation in the standard form. By standard form I mean put everything on left side. So bring this term here, it becomes x square minus 8x plus 15 equals 0. This is the standard form of a quadratic equation. Once you got this standard form, then take coefficient of x square as a, coefficient of x as b, and the constant term is c. Substitute everything here, and even when you substitute b, you need to be very careful. B square, when b is minus 8, don't ever do this. Don't ever write minus 8 square. When you key in this in your calculator, it's gonna multiply 8 times 8, keeping the minus sign there. So you're gonna get minus 64, which is wrong, because you need to square the b. That means minus 8 whole square. So whenever dealing with negative number, it's always a good practice to add the parentheses, so you will get a positive, so you won't make any mistake. So this value of this is supposed to be positive 64. So basically these are all the things that are covered in chapter the subtopic 2.1. Now let's move on to 2.2. Okay, now 2.2, completing the square. There are two exercises, 2C and 2D. You can practice all the sums. So now completing the square. If you know how to solve a quadratic equation by completing the square, much better. So let's say, for example, I have taken this question from exercise 2C. 2x square plus 8x plus 1 equals 0. 2x square plus 8x plus 1 equals 0. They want you to solve this quadratic equation by completing the square. So usually the completing the square is you take the first two terms. If the coefficient of x square, you got some number here, take the number out. So you will have x square plus 4x plus 1 equals 0. Then take the coefficient of x, divide by 2. So when you divide 4x by 2, it's 2. Square it. So you will have x square plus 4x. This 4 divided by 2 is 2. So put 2 square minus 2 square. This is how we solve a quadratic equation by completing the square. Now take these three terms. 2 into x square plus 4x plus 2 square. This minus 4 multiplied by 2 is minus 8. Plus 1 equals 0. You can write this as using algebraic identities. If you have a square plus 2ab plus b square, this equals a plus b whole square. So you can write this term as 2 times a plus b whole, sorry, not a plus b here, x plus 2. X plus 2 whole square. And you have minus 7. Minus 7 equals 0. So you got this. Now you can solve easily. Bring the minus 7 here and 2 here, and you can take a square root on both sides. This is important. This is what called completing the square. But in Pearson Edexcel, if you take a look at your textbook, there is a formula given for completing the square. The formula, if you use the formula, you will never make any mistake. Only thing, you need to memorize the formula. Once you got the formula correct, you can apply the formula for any quadratic function. You just need to plug in the value of a, b, c. It will give you this formula. So let's take a look at the formula. Okay, the formula is a times x plus b upon 2a whole square plus c minus b square upon 4a. This is the formula. The formula looks a little bit of confusing, but once you memorize this formula, it will be much easier. Because when you follow this method, let's say if this number is not divisible by 2, so when you take 2 out, let's say you have a number 5 here. When you take 2 out, it's going to be 5 upon 2. You need to deal with fractions, because half of this will be 5 upon 4. So 5 upon 4 whole square, 5 upon 4 whole square. It's going to be a little bit of difficult, You need to be very careful when you deal with fractions. But if you know this formula, you don't need to worry about anything. Just plug in the value of a, b, c in there, and let's see what we get. A is 2, so 2 times x plus b upon 2a. b is 8, 8 upon 2a is 8 upon 4 whole square. Your c is 1, 1 minus b square. b is 8, so 8 square is 64 upon 4a. 4 times 2, 8. Now when you simplify this, 2 times x plus 8 upon 2 is 8 upon 4 is 2. 1 minus 8, 64 by 8 is 8. 1 minus 8 is minus 7, which is same as this. Which is same as this. You don't need to go through this ordeal. It's easy. You just need to plug in all the values here. It will straight away give you this form. So it's easy for you to solve from here. So I would suggest you to learn this formula. Even I use this formula. This is much easier. This is much easier because here we tend to make mistake. But if you think that this formula is too difficult, just follow the normal completing the square method. So this is the first thing you are going to learn in here. In 2.2. This is a new thing you are going to learn. A times x plus b upon 2a whole square plus c minus b square upon 4a. Okay, look at this question. This question taken from exercise 2c. You are given a quadratic expression involving decimal numbers. They want you to express this in this form. A minus b into x plus c the whole square. This question has 3 marks. So in your exam, whenever you see a quadratic expression and they want you to write this, sometime you'll be given something like this. A plus x plus b whole square minus q or something like that. Whenever you see this form, you must know that you need to apply completing the square method. So we are going to apply completing the square here. I'm going to apply the derived formula, which is much easier. The formula is a into x plus b upon 2a whole square plus c minus b square upon 4a. That's it. Memorize this. It will be much useful. You don't need to worry about anything. Just plug in the values of a, b and c. Our c is the constant term 2. B is the coefficient of x, A is minus 0.04. Substitute here minus 0.04 into x plus B. B is 0.8 divided by 2a, 2 times 8. So minus 0.08 whole square. Then C. Our C is 2 minus b square. When you square this, 0.8 whole square is 0.64 divided by 4a, 4 times 8. So it will be minus 0.16 when you multiply by 4. That's it. Now it's all about simplification. It will be minus 0.04 into x minus plus into minus minus. When you divide 0.8 by 0.08, it will be 10. Use your calculator, please. Plus 2 minus into minus plus. When you divide them, this is a 2 decimal place, 2 decimal digit. So you will get a whole number, not a decimal number. When you divide them, you get a 4. 4 times 0.16 is 0.64. It will be 6. 2 plus 4 is 6. I'm going to write 6 here first. 6 minus 0.04 into x minus 10 whole square. Compare this with this expression. You see, your A is 6. Your B is this number. Only 0.04. If you are given plus b here, you need to take negative 0.04, but you are given minus b. So leave the negative sign for this negative. You take only the value, the absolute value 0.04. And your c is, you have positive plus c here, minus 10 here, so take this minus 10. You have a, b and c, that's it. But again, when you compare this, you need to be very careful with positive and negative sign. And this question has 3 marks. Let's move on to 2.3. 2.3 is basically functions. So functions means you will be given any expression or any function, and you'll be given some x values. You need to replace the x by the given x values. For example, like something like this: f of x is x minus 5 into x plus 2. Find f of minus 7. So replace x by minus 2. So there is only one exercise. If you take a look at the first part of this exercise, all these simple sums for you to practice. But when you move on to the second part of the exercise, that's very important. Why I say this? Because if you take a look at the past papers, every year there is a question from this topic, the second part of this exercise. Okay, this question has been taken from exercise 2E. It's a fourth degree equation. They want you to find all the solutions of this equation. That means it's supposed to have 4 solutions. We don't know how to solve a fourth degree equation, but all we know is how to solve a quadratic equation. So what we are going to do is, you might be given any equation, maybe 6th order, maybe sometime you can see as power 1 by 2 and all. We are going to solve few more sums. First step, you need to convert the given equation to a quadratic equation. How do we convert it? Just take a look at it first. If you replace x square by y, your x to the power 4 will be y square. So this will become y square minus 12y plus 32 equals 0, which is a quadratic equation. And you know how to solve this equation, correct? Once you solve this equation, so this is your first step. Always convert the given equation to a quadratic equation. For example, another question. You are given x minus 7 square root of x plus 10 equals 0. You cannot always take the middle term as y. You can take it as y and check first whether it is converted to quadratic equation. If we take this as y, your y square will be x. So when you substitute here, it will become y square minus 7y plus 10 equals 0. You got a quadratic equation. That is your first step. But bear this in your mind. Not always you have to take the middle term as y. Sometimes you may need to take this term as y, you will get y square here. So that's why you cannot just blindly take the middle term as y. You need to check. You take it as y and check whether you get a proper quadratic equation. Once you got the quadratic equation, the rest all very easy. Just solve them. For example, when you solve here, you can write it as 8 fours or 32. So you will have y minus 8, y minus 4. Use any method, formula or whichever method you are comfortable with. Your y will be 4 and 8. You got 2 solutions. If you stop right here, you lose half of the marks because you got the solutions of y. They are not interested in y. They want you to find the values of x, the 4 values of x which satisfy the given equation, not y. So once you got the values of y, don't stop there, you're going to lose half of the mark. You need to convert this y back to x using this. So your y is x square is 4 and x square is 8 because your y is x square. So when you find x, when you take square root, you get plus or minus 2. Here your x is plus or minus square root of 8. So you got 2 plus 2, 4 values. These 4 values are the solutions of the given equation. That's it. Same goes here. When you substitute here, I think it should be y minus 5 into y minus 2 is 0. So your two y values 2, 5, and again you're not supposed to stop here. Convert this y back to x. Y is square root of x. So square root of x is 2. Square root of x is 5. Now square both sides. Your x is 4 and your x is 25. So you got two solutions here. So they are interested in the values of x, not y. So the first step I repeat again. Whenever you see some weird looking equation with power 5 or power 2 by 3, power 1 by 2, try to convert the equation to quadratic equation by substituting y as some term. You need to check. Once you got the quadratic equation, easy solve it. You got the y values. Replace y back to x and solve again. Okay, now this question taken from October 2019 past paper. You are given this equation. They want you to solve this and write the solution in this form. A plus b square root of c. This question has 5 marks. Again, as I told you, this is not a quadratic equation. So we are going to first step, we need to convert this to a quadratic equation. By taking x to the power half as y, you square both sides, x will be y square. Now convert this back to y. Y square minus 6y plus 4 equals 0. And I'm going to solve this by using formula. So y equals minus b plus or minus square root of, because b is minus 6, minus b will be positive 6. B square minus 4ac divided by 2a. A is the coefficient of y square. When you simplify this, 6 plus or minus square root of 36 minus 16, which is 20 upon 2. 20 can be written as 4 times 5. In thirds we learn if you have 20, you can write it as square root of 4 times square root of 5. Square root of 4 is 2. So you can write this as 6 plus or minus 2 root of 5 divided by 2. Take 2 as a common factor and cancel. You will have 3 plus or minus square root of 5, which is the value of y. Again, do not stop here. This is the value of y. You need to convert this y back to x. So now y is 3 to the power 3 plus or minus square root of 5. Y is square root of x. So square root of x is 3 plus or minus square root of 5. Square both sides. X equals 3 plus or minus square root of 5 whole square. You can apply the algebraic identity a plus b whole square or a minus b whole square and simplify. So you will have x is, first one take it as a plus b whole square. A square plus 2ab plus b square, which is 9 plus 5, 14 plus 6 root 5. When you take the negative, you will get the same answer but negative sign here. So your next x will be 14 minus 6 root of 5. That's it. So you have a plus b root of, I think this is supposed to be plus or minus. So your a is 14, b is 6, your c will be 5. You can write a is 14, b is 6, c is not square root of 5, it's just 5. And you got 5 marks for this question. So now this question taken from your textbook exercise. You are given this expression, they want you to express this in this form. 3 to the power x minus a into 3 to the power x minus b. It's not difficult. Again, as I said, whenever you see a weird looking expression, try to convert the expression to a quadratic expression. So if you take y equals 3 to the power x, your y square will be 3 to the power x whole square, which is 3 to the power 2x. So substitute everything in here. You will have y square minus 28y plus 27. Now you can apply the factorization method. You will have y minus 27 into y minus 1. You don't need to solve this. They just want you to write in this form. Replace y by 3 to the power x. You got the answer already. 3 to the power x minus 27. 3 to the power x minus 1. So this is your A, this is your B, or vice versa. That's it. Okay, this question from January 2020 past paper. You are given two parts. Part A, they want you to solve this cubic equation. And part B, they want you to solve this again, another weird looking equation. So first we solve part A. If you take a look at this, you can take 10x as a common factor. If you take 10x, you will have 2x squared minus 5x minus 3 equals 0. You take the common factor out. If you want, you can just divide by 10 also. It's the same. Divide the whole equation by 10 and take x out. Now you can split them. X equals 0, that is your one solution, and 2x squared minus 5x minus 3 equals 0. That is your another equation. You need to solve this. You'll get another two more solutions. So I'm going to solve this by using you can use any method. 2 minus 3 minus 6. So you have minus 5 and minus 6. You need two numbers. Minus 6 times 1. So 2x squared minus 6x plus x minus 3 is 0. Learn the product sum method, easy. Or you can use formula method also, up to you. Take 2x as a common factor. So you will have x minus 3. Take plus 1 as a common factor, x minus 3 is 0. So your 2x plus 1 into x minus 3 is 0. So x is minus half, x is 3. So we got three solutions. X is 0 and here two more solutions. So once you got three solutions, you score 3 marks. Now let's move on to part B. Part B, you need to compare these two. You can see 20 here, 50 here, 30 here. Almost the same. Only thing, instead of x cube, you have something else. X squared, you have something here. In the place of x, you have this, right? So take x equals this. So take x equals y plus 3 to the power half. If you substitute x equals y plus 3 to the power half here, it will become 30x. This will become square. When you square both sides, this will become y plus 3. So 50x squared, 20x cubed, you got this equation. So what I'm trying to say here, the three solutions that you got here, right? X equals 0, minus half and 3 will be the solutions for this equation also if x is y plus 3 to the power half. So in other words, you can equate all these solutions to y plus 3 to the power half. Y plus 3 to the power half is 0. Take the first one. Then square both sides. So your y plus 3 is 0. Y is minus 3. Now take second one. Y plus 3 to the power half is minus half. You cannot just blindly square both sides and find the value of y. Because if you take a look at this, square root of something is minus half, which is not possible. So this has no solution, leave it. Take the third case. You have y plus 3 to the power half is 3. Square both sides. Y plus 3 is 9. 3 square is 9. Y is 6. So you have two solutions for this equation. That's it. So you may have part A and part B. Part A is solved properly. And part B, do not treat this as a separate question. Always compare with part A so you can find the solutions easily. Now there is this question from past paper again, May 2019 paper. You have two parts, part A, part B. Part A got 3 marks when you solve this cubic equation, and part B has 4 marks. Okay, let's take a look at part A. If you take x out, you will have 2x squared plus 3x minus 35 equals 0. When you equate to 0 separately, x is 0 and 2x square plus 3x minus 35 is 0. And when you solve this quadratic equation, you will have minus 5 and 7 upon 2. I'm not going to solve it. You can use any method. You got 3 solutions already, 3 marks for this question. Let's move on to part A, part B. This is part A, part B. When you compare these two equations, as I said earlier, when you compare, you have 35x, 35 into this. So this has to be taken as x. So your x will be y minus 5 whole square. And if you replace y minus 5 whole square by x, this equation is same as the first equation. You will have 2x square, 2x cube, 3x square minus 35x. So what I'm trying to say here, the 3 solutions that we got for part A, the equation in part A, will be the solution, same solution for this equation if x is y minus 5 whole square. In other words, you can just equate this to all 3 solutions. First one, y minus 5 whole square is 0. So y minus 5 whole square is 0 means y minus 5 is 0, y is 5. And take the second one. Y minus 5 whole square equals minus 5, negative 5, which is not possible. A square of something won't give you a negative number. So this has no solution. Take the last one. Y minus 5 whole square is 7 upon 2. Square root both sides. Y minus 5 is plus or minus square root of 7 upon 2. You need to put plus or minus. It has 2 solutions. So your y will be 5 plus or minus square root of 7 upon 2. So there are 3 solutions. Y is 5 and y is 5 and here y will be 5 plus or minus square root of 7 upon 2. That's it. For this case, when you take square root, it will become square root of negative 5. So no solution. These are all the solutions. You got 4 marks for this question. Let's move on to 2.4. 2.4 is basically quadratic graphs, which is completely new to you. We know how to solve a quadratic equation and find the roots and all. Now in this topic, we are going to sketch the graph. So when you are given a quadratic function, there are certain things you need to take note before sketching the graph. Okay, first thing, quadratic graph is either U-shape or an upside down curve. That is the first thing you need to know. Either U-shape or upside down curve. But when it will be U-shape or when it's going to be upside down? By looking at the equation, by looking at the quadratic function, you can say the graph will look like either one of these. So that's what we are going to learn. Sketching the graph, and then sometimes they may ask you to find the turning point, minimum point or maximum point, or the equation of the line of symmetry, and the points where the curve crosses the coordinate axis, or in other words, y-intercept and x-intercept. Okay, let's take a look at a question from exercise 2F. You are given a quadratic function. They want you to sketch the graph, plot the turning point. It can be either maximum or minimum, and the x-intercept, y-intercept, line of symmetry, everything. So what is the first thing we do? You need to solve the given function, given quadratic function. Take it as equal to 0. X square minus 6x plus 8 equals 0. So this will be minus 4 times minus 2. So you will have x is 2 and x is 4. You can solve by using any method. You got 2 points already. Now we are gonna sketch this graph. X and y axis, xy plane. Label the axis. Now take this point 2 and 4. Let's say 2 is here and 3, 4 is here. Now the next thing, we need to know whether it's a U-shaped curve or upside down curve. How do we know that? By looking at the coefficient of x square. bear in mind, if the coefficient of x square is positive, it will be a U-shaped curve. If the coefficient of x square is a negative number, it will be a curve like upside down. So here our coefficient of x square is positive, so the curve will be U-shaped curve. So before you sketch the curve, you need to know the y-intercept. Y-intercept is simple. You need to replace x by 0 here, or in other words, just the constant term. That's your y-intercept. So let's say somewhere here, 8 is here. We got all these points, we can sketch the graph. Graph is not perfect, but this is the graph. You can label the graph x square minus 6x plus 8. So whenever you sketch a graph, because there are some chapter completely dealing with graphs and transformations and all, make it as a practice. Always label the axis, show the point of intersection, and label the graph. That's very important, because sometimes you are going to draw 2 or more graphs in a single xy plane. So you need to label the graphs to show them, to differentiate the graphs. So label the graph. Okay. Now, next thing, the turning point. Okay, you need to know one thing. In this graph, if you take a look at any point on this graph, maybe I take some point here, the y value will be positive more than 8, 10, 9, 8, 7, 6, 4. The y value is decreasing. At some point, let's say this is minus 2. This y value is minus 2 here. X value we don't know. After this minus 2, your y value is going to increase again. Y value is coming down all the way to minus 2 and it's going to increase again. So this point is called minimum point, because that is where y has minimum value. If you take the upside down curve, your y value is going to increase all the way until it reaches the maximum value, and it's going to go down again. So this point is called maximum point. For this curve, it's minimum point. Okay, so if they ask you to find minimum or maximum point, you need to write very clearly it's minimum point. If they want you to find minimum value, you write the coordinate, the y coordinate as the minimum value. But it's not minus 2. You need to find the y coordinate. How do we find the y coordinate? If you can write this equation, the given function in this form, a into x plus p whole square plus q. If you can write this function in this form, your turning point will be minus p comma q. That means when I say this, the first thing comes to our mind is completing the square. Use completing the square to convert this function to this form. Once you converted to this form, you can take this value, negative of this value, and q. This will be your turning point. Or if you apply the derived formula that we learn in completing the square, a into x plus b upon 2a whole square plus c minus b square divided by 4a. You compare these two. What is your a is a? What is our p? P is b by 2a. So in other words, this point is minus b by 2a because minus p. And q is whatever the term here, which is c minus b square upon 4a. So you can either convert this to this form and find the turning point, or you can straight away write the turning point as minus b by 2a. For example, in this equation, a is 1, b is minus 6, c is 8. So I'm going to find the turning point straight away using this form. So the turning point will be minus b upon 2a, minus 6 upon 2a. 2a is 2, comma, c minus b square minus 6 whole square, which is positive 36, divided by 4a. 4. That's my turning point. So when I simplify, it will become positive. 6 by 2 is 3, comma. 36 upon 4 is 9. 8 minus 9 is minus 1. So this point is minus 1 and 3. Sorry, 3 and minus 1. 3 and minus 1 is our turning point. For this particular graph, it is the minimum point. I'm going to explain this one more time. Whenever you are given a quadratic function, first solve and find the two values, that is your x-intercept. Then replace x by 0. Replace x by 0, you will get the y-intercept 8. Y-intercept is 8. And then the next thing, take a look at this coefficient of x squared. Don't ever miss out. Don't always draw this graph. It can be a negative number, negative something. So it has to be upside down graph. So take a look at this coefficient of x squared. If it is positive, then proceed to draw this, sketch the graph. And label the axis clearly. X, Y, origin O. Then the graph x squared minus 6x plus 8. And plot the points. You can write it as 0, 8, 2, 0, 4, 0 also. Up to you how you want to write. But don't swap the number. Don't put 8, 0. That's wrong. Because here x coordinate is 0, here y coordinate is 0. And then the next thing, you need to find the turning point. So how do we find the turning point? You take the function, quadratic function, and find a, b, c. You know the a, b, c. A is a quotient of x squared, b and c. You can straight away substitute in this formula. Minus b upon 2a, comma c minus b square upon 4a. If you don't want to do that, that's completely fine. Convert this function to this form. A into x plus p the whole square plus q. Then your minus p comma q is the turning point. Can be either maximum or minimum. So these are all the things you need to do. That's it. Now you got the y-intercept, x-intercept, and we got the shape of the curve by looking at the coefficient of x squared. If it is positive, U-shape. If it is negative, upside down. And the turning point. Then line of symmetry. Line of symmetry is very easy. Just draw a line here. The equation of this line is, this line is the line of symmetry for this parabola. So what is the equation of this line? Any line parallel to y-axis will have this equation, x equals a. The a is 3 here because you take any point on this line, the x coordinate will be 3. So x equals 3 is the line of symmetry. In other words, once you got the turning point, you know the x coordinate, right? Write it as x equal to the x coordinate. That is the equation of the line of symmetry. That's all. These are all the things you need to learn here in this quadratic graph. X-intercept, y-intercept, shape of the curve, and then turning point, line of symmetry. Okay, again, when you solve the first step, I ask you to solve the equation. Sometime you will get only one solution. For example, let's say we are given this equation, x squared minus 6x plus 9. When you try to solve this, you will get x equals 3. Some people write it as 3, 3. Two solutions, but they are same. So you got only one value. So don't get confused. Even if you get one value, plot this, label the axis and the origin. Now your x-intercept is 3. 1, 2, 3. Let's say 3 is here. Now the coefficient of x squared is positive, so it's a U-shaped curve. And when you replace x by 0, your y-intercept is 9. Y-intercept will be 9, somewhere here, let's see. Now how do we sketch the graph? Because x-intercept, there is only one x-intercept. That's okay. Just draw a U-shaped curve that touches x-axis at the point 3. This will be your graph. Sometimes you will have 2 points. That means the curve is going to pass through the x-axis. Sometimes only 1 point. That means the curve touches the x-axis at a particular point. And there is one more case number 3. When you try to solve, you cannot solve. For example, x squared plus x plus 1. When you try to solve this, you cannot solve by factorization. When you use the formula minus b plus or minus b square minus 4ac upon 2a. So minus 1 plus or minus, you will have 1 minus 4, which is minus 3. You have a square root of a negative number, which is not possible to solve as of now. When you move on to higher classes, you will learn something about something like imaginary numbers, complex numbers, where square root of a negative number is possible. But for now, in our book, AS level book, the complex number is not included. So whenever you see square root of a negative number, take it as like no solution, because you cannot find the value of a negative number. So if no solution, that means the curve is not going to touch the x-axis at all. Your y-intercept is 1. So let's say y-intercept is 1. And find the turning point. Find the turning point. So your curve will be something like this. It's not going to touch the x-axis. That's the difference. So there are 3 scenarios. One is going to pass through the x-axis. Another one is going to touch the x-axis at some point. Case number 3, curve will be somewhere there. It's not going to touch x-axis. This question is taken from your textbook exercise. We are going to sketch this graph and find the turning point, line of symmetry and everything. So as I already said, the first step, you need to solve this. Take it as minus x squared plus 6x plus 7 equals 0. You can multiply everything by negative 1. X squared minus 6x minus 7 is 0. So easy to solve. So if you take minus 6 and minus 7 and positive 1, you get this. When you multiply minus 7, add minus 6. So your solution is x is minus 1 and x is 7. You got 2 solutions already. These are all the x-intercept points where the curve meets the x-axis. Now y-intercept, when you replace x by 0, your y-intercept is 7. You got the x-intercepts, y-intercept. Now what is the coefficient of x squared? Don't ever forget this. Don't always go and draw U-shaped curve. This is upside down curve because the coefficient of x squared is a negative 1. So take x and y. Your x-intercept minus 1 and 7. So take minus 1 here, 1, 2, 3, etc. Let's say 7 here. Minus 1 and 7. Y-intercept 7. 7 here. So the curve will be upside down curve. So it will be something like this. This is our parabola. Minus x squared plus 6x plus 7. Minus x squared plus 6x plus 7. And the next thing, you need to find the maximum point. For the upside down curve, the turning point is the point where the curve will have maximum value, the maximum point. How do we find the maximum or minimum point? You use this formula, minus b upon 2a, comma c minus b squared upon 4a. I prefer this actually because straight away you can substitute the values of a, b and c. So our a is minus 1, b is 6, c is 7. Do not take this equation where you change the negative to positive. Take the actual equation, actual function. So when you substitute here, minus b divided by 2a, 2 times minus 1, minus 2, comma c minus C is 7 minus B square is 36 upon 4a, 4 times minus 1 is minus 4. And simplify this, 6 by 2 minus into minus plus, so 3 comma, so it will be 7 plus minus into minus plus, 36 by 4 is 9, 7 plus 9, 16. So you have 3 and 16 somewhere here. My graph is not perfect, so it's supposed to be 3 comma 16. You got the turning point, the maximum point already, 3 comma 16. If the question says what is the maximum value of the function, when they say value of the function, you always take the y value. So 16 is the maximum value of the function. Now draw a line here. This line is the line of symmetry. The equation is x equals the x coordinate 3. That's it. First solve, find x-intercept. Replace x by 0 to find the y-intercept. Look at this is very important. Look at the coefficient of x squared. If it is positive U-shaped curve, for this it's negative, so it's going to be upside down curve. Then find the turning point, minus b by 2a, comma c minus b square upon 4a. If let's say you forgot this, suddenly you don't remember this. Okay, don't worry about it. Apply the completing the square method. You need to apply the completing the square. Take minus 1 now. You will have x square minus 6x plus 7. Always take the minus out. It will be easier. Take half of 6, which is 3. So put 3 square plus 3 square minus 3 square. If you forgot the formula, suddenly you don't remember the formula, just apply the normal completing the square method. So minus 1 into these 3 terms, x square minus 6x plus 3 square. Minus 3 square is 9, minus 9, minus into minus plus. So you have plus 7. Sorry, not plus 10. Minus 1 into minus 9 is plus 9. So you can write it as minus 1 into x minus 3 whole square plus 16. You got this form already. Now it's easy to find the turning point. Take the number here, change the sign. Your number is minus 3. So change the sign, it will be positive 3. And take this value together with the sign. If it is negative 16, take negative 16. In this case, it's positive 16. That's your turning point. You can find the turning point. That's all. Let's move on to 2.5. Okay, in 2.5, subtopic 2.5, discriminant. Discriminant means this. B square minus 4ac. When you look at the quadratic formula, you usually write square root of b square minus 4ac. This without the square root. B square minus 4ac is called the discriminant. Why do we need this discriminant? By looking at the value of this discriminant, it can be a positive number or 0 or a negative number. We can predict how the quadratic graph will behave, how the graph will look like. For example, let's say your b square minus 4ac is greater than 0. When I say greater than 0, it can be a positive real number. Positive real number. Your graph will pass through x-axis. You will have this type of graph. It will pass through x-axis. That means you will have 2 points of intersection. It can be an upside down graph also. But the point here is you will have 2 solutions. That's the first case. And number 2, if your b square minus 4ac equals 0, when it is equal 0, the graph will touch the x-axis at only one point. We don't know where the point is, but it will touch the x-axis at one point. Even for the upside down curve, it will touch the x-axis at exactly one point. What will happen? Your b square minus 4ac less than 0. When I say less than 0, it's a negative number. So in the quadratic formula,
you will have square root of a negative number here. When this is less than 0, you will have square root of a negative number, which means no solution. No solution means the graph will not touch the x-axis at all, even for the upside down graph. It will not touch the x-axis. These are the three things that you are going to learn in discriminant. That's it. b square minus 4ac is greater than 0 means greater than 0, or sometimes it will be given positive real roots. That means 2 roots. If it is equal to 0 at only one point, less than 0 means it's not touching. Okay, this is your textbook question. You are given a quadratic equation x square plus 6x plus k. Here supposed to be a number, real number, but they have given you a constant k. And this equation has two real solutions. So find k. This question has 2 marks only. How do we approach this question? You need to read the question first, word by word, carefully. This equation has 2 real solutions. That means this is a positive, the coefficient is positive. So the graph will pass through x-axis. So what is the condition? If the graph passes through the x-axis, your discriminant b square minus 4ac should be greater than 0. That is the condition. So now plug in the values for b, a and c. You will get the value of kl. Your b is 6. So 6 square minus 4 a c. C is k. That's it. Solve this inequality. You got the value of k. So 6 square is 36, is greater than 4k. Minus 4k comes here, becomes plus 4k. Divide everything by a positive number. 9 greater than k. Just flip it. K less than 9. That means k doesn't take a particular value. K can be anything lesser than 9. That on your number line, let's say 8, 9 here, your k is this 10, 11. We put a little circle here because 9 is not included. So this is k greater than, it's less than 9, supposed to be here. K less than 9. These are all the values of k. That's it. Here, one more thing, you need to be very careful. Whenever dealing with inequality, when you divide or multiply both sides by a negative number, you are supposed to flip this sign. Let's say, for example, you got 36 greater than minus 4k. And you want to find the value of k. You divide both sides by a negative number. So 36 by minus 4. Flip this sign. Minus 4k divided by minus 4. So it will be minus 9 less than k, or k greater than minus 9. You need to be very careful on this. Whenever multiply or divide an inequality by a negative number, flip the sign, please. So that's it. We got the values of k already. This question has 2 marks. If the same question says this function has only one solution. Only one solution means it is equal to 0, equal 0, equal. So 9, k is 9. K takes only one particular value. If they say this function has no real solution, you have to put less than 0 because no real solution. So everything will be less than. So here less than. So when you flip it, k greater than 9. That's it. Nothing else. Now this question, 3 upon x plus 5 equals minus 2x plus c, has no real roots. Find the range of possible values of c. This question has been taken from Jan 2019 past paper. And surprisingly, this question has 7 marks. So, how do we find the possible values of c?
we are going to use the three cases that we learned in discriminant. First thing, we are going to convert this to a quadratic equation by multiplying everything by x. So when you multiply everything by x, it becomes 3 plus 5x equals minus 2x squared plus c. Multiply each and every term by x. The first term, the x will be cancelled. This will become 5x minus 2x squared c times x. That's the first step. And second step, put everything on one side of this equation. Everything, bring it here. So it becomes 2x squared minus cx. So you can write it as 5 minus c times x, because you have 5x here minus cx, plus 3 equals 0. So this is the first step you do. You can be given any weird looking equation, convert them to a quadratic form, the general form of the quadratic equation. Now, as I always say, you need to read the question word by word very carefully. It says, this equation has no real roots. In discriminant we learned, if a quadratic equation has no real roots, that means the quadratic equation, the curve is not going to touch the x-axis. Or maybe curve can be this. It's not going to touch the x-axis. Or in other words, the discriminant b square minus 4ac should be a negative number, less than 0. So in this equation, your a is the coefficient of x square, and your b is the coefficient of x, your c is 3, the constant term. Since this equation has no real roots, we know for sure that discriminant b square minus 4ac should be a negative number, less than 0. That's why you need to read the question very carefully. Sometimes it might be like, the question has 2 equal real roots. When they say 2 equal real roots, your b square minus 4ac equals 0. When they say 2 distinct real roots, your b square minus 4ac should be a positive number, positive real number, greater than 0. In this case, no real roots, so we use less than 0. Now substitute all the values here. 5 minus c whole square minus 4 times 2 times c. C is 3. Okay, don't mix up these two c's. This is the constant term actually. Less than 0. Now when you expand this, becomes 25 a minus b whole square. Use the algebraic identity. Minus 2ab, which is minus 10c, plus b square minus 4 times 3, 2 times 3 is 24, less than 0. Or when you simplify this, you get c square minus 10c plus 1 less than 0. So you need to solve this quadratic inequality. But actually, if you look at this, the quadratic inequality comes in chapter 3. Chapter 3. This question is a mixture of chapter 2 and 3. But anyway, I am going to solve this. But when we move on to chapter 3, I am going to teach you how to solve a quadratic inequality. Now you haven't learned that, but this question is not solely from chapter 2. This is a mixture of chapter 2 and 3. Because after this, if you want to solve this quadratic inequality, you need to know how to solve a quadratic inequality. But don't worry about it. Take it as a normal quadratic equation. C square minus 10c plus 1 equals 0. Solve this by using any method. I'm going to use the formula method. So A is 1, B is minus 10, C is 1. So the formula is minus B plus or minus square root of B square minus 4AC upon 2A. Because 4AC will be 4. It will become 10 plus or minus square root of 96. 96. You can write it as 48 times 2 or 4 times
24. 4 times 24 if I am not wrong. 80, 96 upon 2. The reason why I am writing like this, you can take the square root of the 4 outside becomes 2. 10 plus or minus 2 root of 24 upon 2. Take 2 as a common factor and cancel out. You will get 5 plus or minus square root of 24. You can cancel these 2. 2 times 5 is 10. Now you can simplify this. 6 times 4 is 24. You can write it as 2 square root of 6. You got 2 solutions already. Now straight away you can write the values of C. You take a look at these 2 values. The smaller value, 5 minus 2 root of 6, less than C, less than the bigger value. So this is the solution. And you might be surprised how I have written this after this step, which I'm not going to explain now because it's in chapter 3. When you learn solving quadratic inequalities, you are going to learn how to write this solution. But now all you need to know, this is less than 0. This is less than 0. So when you solve, you get 2 solutions. You put the smaller solution here, less than C, less than the bigger number here. That's it. This is the set, the range of all possible values of C. It satisfies this equation when this equation has no real roots. So this question has 7 marks. One more question. This question from exercise 2G. You are given an equation g of x equals x square plus 3px plus 4p minus 3 equals 0 has 2 equal roots. There are 3 conditions. One is b square minus 4ac. When the question says no real roots. If the question says 2 distinct real roots, it's supposed to be greater than 0. If it is 2 equal roots, you need to use this condition, b square minus 4ac equals 0. So we are going to take the values a, b and c. This whole thing is c. Substitute here. B square minus 4ac equals 0. So plug in the values for a, b, c. B square, which means 3p whole square, 3p whole square minus 4 times a is the coefficient of x square, and c, 14p minus 3 is 0. Solve this equation. 3p whole square is 9p square minus 4 times 14, 56p plus 12 minus 4 into minus 3 plus 12 equals 0. Is there a common factor? 3, 26. I don't think there is a common factor. So you need to solve this equation. You can use like formula method or factorization. I'm going to use the factorization method. Take b and ac. Your b is minus 56. Your ac is 9 times 12, which is 9108. Okay, that's some huge figure. Now you need to look for 2 numbers which are added to minus 56 multiplied to 108. Or if you want, you can do that by looking at the factors of 108. You're allowed to use your scientific calculator. Plug in these values, it will give you straight away the values of the 2 values of x. That's much easier. But if you want to use the factors and find out, let's look at the factors of 108. You can write it as 2 times 54. There you are, you got the 2 factors already. Minus 2 minus 54, minus 2 minus 50. And substitute here, 9p square minus 54p minus 2p plus 12 is 0. And then factorize them. 9p into p minus 6. 9 6s are 54. minus 2 into p minus 6. So your two factors are 9p minus 2 p minus 6 equals 0. So your p will be 2 upon 9 or 6. You will have two values for p. But the question, I miss out one more data here. The question clearly says p, I forgot to write down here. The question says p is an integer. So p is an integer. This is not an integer. So take only 6. Your answer is 6. If nothing is stated here, you got two possible values for p. Since the question says p is an integer, only take the integer, not the fraction, not the decimal number. So p is 6. We got our first part already, part A. Part B, they want you to solve this equation. Before you solve, plug in the value here. Replace p by 6 here. Replace p by 6, so it becomes x squared plus 3 times 6, 18x, plus 14 times 6 minus 3. 14, 6 is 64, 6 are 24, 84, minus 3, 81, if I'm not wrong. Now solve this straight away. You can say it's x plus 9 into x plus 9 is 0. So your x is 9. That's it. Probably you'll get 2 marks for this. That's it. So what I'm trying to say here, whenever you have this type of questions, pay attention to this data and something like just now I missed out one more data here. P is an integer. That's also very important. That's why you need to read the question very carefully. Now I'm going to solve few questions from this chapter review exercise. Question number 1, they ask you to sketch this graph. Sketch the graph for this quadratic function 6 minus 10x minus 4x squared. First thing what we are going to do is you need to solve this quadratic equation and find the roots. So when you write it as an equation, minus 4x squared equals 0, and solve this equation. Maybe you multiply everything by minus, it becomes 4x squared plus 10x minus 6 is 0. Or divide by 2, 2x squared plus 5x minus 3 is 0. Now use any method to solve this equation and find the two roots of this quadratic equation. I'm going to use a product sum method. Take b and ac. Your b is 5, ac is 2 times minus 3, minus 6. So you can take it as 6 minus 1. 6 times minus 1 minus 6, 6 minus 1 is 5. So 2x squared plus 6x minus x minus 3 is 0. Take 2x as a common factor from these two terms. You will be left with x plus 3. Here take minus 1, you will be left with x plus 3 again. So it's 2x minus 1 and x plus 3 equals 0. So your two roots are x equals half, x equals minus 3. You got two solutions already. These two solutions are the x-intercept and you need to find the y-intercept. Y-intercept means replace x by 0. So your y-intercept is 6. So you got two x-intercept and when x is 0, your y is 6 here. When you substitute x is 0, y is 6. That is the y-intercept. That is where the curve crosses y-axis. Now another important point, you need to take a look at the coefficient of x squared, whether it's a positive number or negative number. If it is a negative number, the curve is going to be upside down. Now the two solutions, minus 3 and half. So let's say your minus 3 is here, 1, 2, minus 3 is here, and half is here. And your y-intercept is 6. Let's say 1, 2, 3, 4, 5, 6 somewhere here. And we know the graph is going to look like this. That's completely wrong. This will be your graph. Y-axis, x-axis, origin. This will be your graph. Because the maximum point, this is not the maximum point. The maximum point can be somewhere here. And how do we find the maximum point? We know already the maximum point is minus p comma q. Using this function, you can find the maximum point. You plot the maximum point and the line of symmetry. Now, how to find the turning point? You need to have minus, the turning point is minus p comma q, or minus b by 2a comma c minus b square upon 4a. This is going to be your turning point. Substitute the values for a, b, c. A is minus 4, b is minus 10. So b is minus 10, a is minus 4, 2 times minus 4 is minus 8, comma c minus c is 6, minus b square minus 10 whole square is 100 upon 4a, 4 times minus 4, minus 16. So your minus will be cancelled. 5 upon 4 minus 5 upon 4, comma, here it will become plus 6 plus 100 upon 16. So this will be minus 1.25, comma, this will be 16 plus 36, 96, 196. It will be 12.25. This is going to be your maximum point, the turning point. Our 6 is here, so 12 is supposed to be somewhere here. So you need to rearrange, but that's okay. That's okay. As long as you mention the point here above 6. And this will be minus 1.25, comma 12.25. That's the maximum turning point. And the line of symmetry, as I told you already, take the x coordinate, write it as x equals minus 1.25. That's the equation of the line of symmetry. And label the graph 6 minus 10x minus 4x squared. That's it. Question number 2. You are given this function, quadratic function. They want you to convert this in this form, p into x plus q whole square plus r. So first thing, you need to remove the bracket and simplify. So it becomes 3x square minus of a plus b whole square, which is a square plus 2ab plus b square. Simplify this, it becomes 2x square minus 2x minus 1. So you got the equation, the function already in the general form, standard form. Now apply the formula for completing the square. You can apply this formula, a times x plus b by 2a whole square plus c minus b square upon 4a. You need to memorize this. If you don't know, take 2 out and apply the completing the square method. Now when you substitute the values for a, b, c, your a is 2, b is minus 2, c is minus 1. So a is 2, x plus b upon 2a plus c, your c is minus 1, minus b square minus 2 whole square upon 4a. And just simplify this. X minus half, 2 and 4 can be cancelled. Here you will have minus 1, 4 upon 8 is 1 upon 2, which is 2 into, sorry I missed out the square, 2 into x minus half whole square minus 3 by 2. When you compare these two, your p is the number outside the bracket, q is, they say plus q, so you can write it as plus of minus of. So your q is minus of and r is minus 3 by 2. This is the easiest method, but if you think that memorizing this formula is a bit difficult for you, you don't need to memorize this formula. You can straight away apply completing the square here. Take the common factor from these two terms, common factor is 2, you will have x square minus x minus 1. Now look at the coefficient of x, which is 1. X square minus x. The coefficient of x is 1 divided by 2, which is half. So you put plus half square minus half square minus 1. That's how we do the completing the square method. Take the first 3 terms. You can write it as a minus b whole square. The first term x square, this is half square, so you can write it as x minus, because when you expand this a minus b whole square, you will get these 3 terms. And here you will have 2 times minus 2 times 1 upon 4 minus 1, which will be minus half minus 1 minus 3 by 2, which is same as this. It's up to you which method you want to use. But here you need to be very careful when you simplify the numbers. Question number 3, you are given a function 2 to the power 2x minus 20 times 2 to the power x plus 64. X belongs to R. This R means set of all real numbers. So if you get a complex, you don't know what a complex number is. If you don't get a real number, that means a square root of a negative number, just ignore. Only take the real number. Now, part A, you need to write this function in this form. How do we do that? First, look at this given function. If you replace this by y, 2 to the power 2x, take it as y. So your y square will be 2 to the power x whole square, which is 2 to the power 2x. So you replace everything by y. You will get y square minus 20y plus 64. Y square minus 20y plus 64. Apply the product sum method, the factorization method. 64, 8 times 8, it's not gonna work. 16 times 4 is 64. So minus minus. So you will have y minus 16 into y minus 4. Because when you multiply, you get plus 64. When you add them, minus 20. So you got this form already. Replace y by 2 to the power x again. 2 to the power x minus 4. That is your part B. You can put this term first also, it doesn't matter. And part B says, solve this equation. They want you to solve this equation in part B. How do you solve? Take it as equal to 0 and separate them. 2 to the power x minus 16 equals 0. 2 to the power x minus 4 is 0. So 2 to the power x is 16. 2 to the power x is 4. And if you want to find x, write this number as a power of 2. Can be written as 2 to the power 4 is 16. Here 2 to the power 2 is 4. So your x is automatically x equals 4 and x equals 2. You got 2 solutions, 2 and 4. That's it.